Alright, so in the last video we talked about some terminology and we introduced a little bit of vocabulary and some definitions. And now let's do a quick example here. This is hopefully review from your pre-calculus days, but it's good to review and also to extend the idea just a little bit more. So we're going to approximate the area underneath the curve or between the curve and the x-axis from 0 to 2 of x to the third dx. So now I've drawn the graph of this, and this is 2, and we want to use 4 equal subintervals. And since the length is 2, then each subinterval is 2 over 4 or 1/2. So this is 1, this is 3/2, and this is a half, and that there is of course 0. Okay. So let's start out by approximating this using the left sum. So L of 4 here is equal to, and since we're using the left sum, we're going to use the left side value. So we're going to use the area of this blue rectangle, of these blue rectangles here. And you can see that in this case we're going to ignore the very far right extreme here. So this is how we can list it out. Each of these rectangles have a base of 1/2. Now the first one actually has a height of 0. Okay? So this is 1/2 times f of 0 plus 1/2 times f of 1/2 plus 1/2 times f of 1 and 1/2 times f of 3/2. So I have 1, 2, 3, 4 sums. So we could factor this out and we get 1/2 times f of 0 plus f of 1/2 plus f of 1 plus f of 3/2. Then we can substitute that into, then we can actually make these substitutions into f of x and calculate and get some numbers. So f of 0 is just 0. F of 1/2 is 1/2 cubed or 1/8. F of 1 is just 1, and f of 3/2 is 3/2 cubed or 27 over 8. So add that all up and then multiply by 1/2. So that comes out to 9 over 4. Okay. So that's the left sum. Let's do the right sum. Now the right sum is going to be the exact same, almost the exact same thing, except instead of using the left terms, we're going to use the right side of these rectangles. So our first rectangle is going to be this red one. Our second rectangle is going to be that. Our third one is going to be this. And our fourth one is going to be this one right here. Okay. So what's important here is these points. This is f of 1/2, f of 1, f of 3/2, and f of 2. So the right side sum here, or the right rectangle approximation method, you can see here each of the bases is still going to be 1/2, but these heights of the rectangle is going to be a little bit different. It's going to be f of 1/2 plus f of 1 plus f of 3/2 plus f of 2. And that gives us 1/2 times 1/8 plus 1 plus 27 over 8 plus 8. So if we add all of that up, we should get 10.25 or 41 over 4. No, wait. That's not it. I'm sorry. It should be 6.25 or 25 over 4. Okay. Let's keep going. this time, let's calculate the trapezoidal sum and then the midpoint sum. Okay. So the picture that we had before was quite cluttered, so I just redrew it, and I also drew in all of the trapezoids here by these blue lines. Okay. So essentially, what we're trying to do is calculate the area of each of those trapezoids and then just add them up. Now, the formula for a trapezoid is 1/2 the height times the two bases. So for this first one, we got 1/2. The height is actually this length right here, and then this length right here is the base. Okay. So the height here is 1/2. The first base is actually f of 0, and the second base is f of 1/2. Okay. Plus the area of the second trapezoid, so that's 1/2. The height, which in this case is also 1/2, times the sums of the bases. So the first base of this one is f of a half plus f of 1. Okay. Next, 1/2 times the base, times the height, times the next base, which is f of 1 plus f of 3/2. And then 1/2 times the height times the sum of one of the bases times the sum of one of the bases and the other base. Okay. So we got this expression here. All we have to really do is evaluate each of it. But before we go further, I always like to factor things out if that's at all possible. So t of 4, you can see here that all of these terms have 1/4 in them. So I can pull out a 1/4. And then you can see here that I have a f of 0. I have 2 f of halves. I have 2 f of 1. 2 f of 3/2, and 1 f of 2. Okay. And this is the way it's always going to be with the trapezoidal sum, just because you're reusing this base here twice, once for the first trapezoid and once for the second trapezoid. Okay. So now let's put these numbers in and crunch the numbers out in your calculator. So I did all of that, and these are the numbers that I got for f of 0 is just 0, f of a half times 2, f of 1 times 2, f of 3/2 times 2, and f of 2, and where I worked all that out, and I got 17 over 4, or 4.25. So this is t of 4. Now, we'll do this one more time, and this time we'll be able to figure out, we're going to figure out what the midpoint sum is. Okay, so with the midpoint sum, we are basically going to the midpoint of each of these. And I'll do it on one of these, the other points. So between 1 and 3/2 is its midpoint. We're going to go up to the curve and make this rectangle. Between 3/2 and 2, find the midpoint, go up to the curve, and make a rectangle. And then between 1/2 and 1, go find the midpoint, go up to the curve, not to the blue dash, but to the curve, and then make the rectangle, and then down here, and make the rectangle. Okay. So again, we have 4 rectangles. Each one of them still has a width of 1/2, but the heights are a little bit different. So it's going to be, each one of them has a width of 1/2, and the height, though, is going to be f of 0.25, because that's between 0 and 1/2. Then f of 0.75, or 3/2, because that's between 1/2 and 1. 3/4, I'm sorry. F of, this is between 1 and 1.5, so 1.25, or 5/4. And then this is between 1.5 and 2, so this point here is 1.75, or 7/4. So we're going to calculate that and then just add all of it up. So this is 1/2. F of 1/4 is 1 over 64, plus f of 3/4 is 27 over 64, plus f of 5/4 is 125 over 64, and f of 7/4 is 7 cubed over 4 cubed, 343 over 64. Okay. So I can, if you had to do this on a non-calculator multiple choice, well, we could factor out 1/2 and 1 over 64, and just add all this up. 1 plus 28 plus 125 plus 343. And adding all of that up will give us 1 over 128 times 497, which is 497 over 128. For the decimal approximation, it's about 3.883. So there you have it. All 4 different methods: left, right, trapezoid, and midpoint, of how to calculate this. So this is a little bit tedious, but it's important for you to understand how to do these calculations. It's important for you to be able to express this expression right here in terms of f, and then also maybe do some extra calculations and express this right here. Your calculator will, of course, take care of the rest. You are expected to know how to expand in terms of f, and then in some cases calculate what these f values are. If you're in an AP class, you're going to be expected to calculate these f values on some sort of non-calculator exam. Thank you for watching. Have a wonderful day. Remember to watch the next video where we discuss over approximations and under approximations of these values.